This question is about 2-methyl-but-1-ene. So but-1-ene with a methyl group on number 2. Name the reaction for 2-methyl-but-1-ene with concentrated sulfuric acid. Outline the mechanism to form the major product. So this is a reaction of an alkene. Alkenes are attracted to electrophiles and they are added on, so electrophilic addition. Now I'm going to draw my alkene out. So I've got our carbon number 1 where the double bond starts. And then on carbon number 2 we've got a CH3 and then we've got a CH2, CH3. So it's like here and here. So it's got carbon number 1, 2, 3, 4, and then we've got this branch. And then for sulfuric acid, we're going to show that as a hydrogen bonded to the oxygen, which is bonded to the sulfur, which is bonded to 2 double bonded oxygens and then a single bonded OH. So I'm going to have a curly arrow from the centre of the double bond, from the centre of the double bond to the hydrogen, and then from the HO bond to the oxygen. I'm going to make my alkene, which is currently doing a kind of a star jump shape. I'm going to make it do a split, a box split. It's going to spread everything out. Move all the groups out of the way. Now the question wants the major product. So when we're putting the hydrogen on, we want to be able to put the plus on the more stable carbocation intermediate. If I were to put the plus on this first carbon, it would be a primary, but if I was to put it on the second carbon along, it's going to be a tertiary. So I'm going to put it on the second carbon, which means I'm putting a hydrogen on the first. Then we've got our hydrogen sulfate group, OSO2OH, lone pair on the oxygen and a minus sign. And in that goes to the carbocation, creating the major product and it says draw the structure of the minor product. So when we got to this point where we'd spread everything out of the way, this time, instead of putting the hydrogen on the left carbon, we're going to put it on the right, which means our group, our O, and I'm just going to draw a bond here because keep the atoms away from each other, to our SO2OH. And it says explain why this is the minor product. Well, so our other product, the major product, was formed via a tertiary carbocation so a tertiary carbocation intermediate which is more stable than the primary as 3 alkyl groups have a greater positive inductive effect than 1. The next part of the question says draw the skeletal formula of a functional group isomer. So this is of an alkene, so we need to not be an alkene, so we probably want to be an alkane, but we want to be a cyclic alkane. So we need any cyclic alkane that has 5 in total carbons, so that might be that we draw a pentagon. We could draw, for example, a cyclobutane with a methyl or a propane with 2, but we only need one answer, so I'm going to leave it as cyclopentane. 2-methyl-but-1-ene can form a polymer, remembering that our structure looked like this. There was our 1-ene with a methyl group on number 2. And there's the rest of our bute. The type of polymerization from alkenes is called addition polymerization. And when our what looks like a starfish wants to make a polymer, it's going to do a parallel stretch, reach its arms out to either side, and stretch up and down. So we're going to go CH3, H, H, CH2, CH3.